Hello and welcome to another Kiki tutorials made just to spite Guy during Guy's Tutorials call. A pair of students are pulling a small homecoming float with a net force of 150 newtons. The velocity of the float as a function of time is shown in the graph. Given this data, what is the mass of the float? Looking at the graph, you can see that the x-axis is time, in seconds, SI units, and the y-axis is velocity, also in SI units. We know the slope of this graph is acceleration because if we do rise over run, the rise being velocity, the run being time, velocity over time, rise over run, velocity over time we know equals acceleration, so finding the slope means finding the acceleration. So if we look at the question to see what we're given, we can see that we're given net force, 150 newtons. Everything else that's given we can find in the graph. So all that you need to note now is that it is a net force of 150 newtons, and you can see that we are looking for the mass. It says, given this data, what is the mass of the float? So given 150 newtons, find the mass, and you're given the data in the graph. So now we want to establish the relationships and solve for mass. So mass, what does it equal? We can think, what equations do we know that involve mass? So there's acceleration equals net force over mass. You can rearrange the equation to be equal to mass. So adding, multiplying by mass on both sides, you get F net equals ma, and then divide by acceleration on both sides to get m alone. So now you have mass equals net force over acceleration. So what we've done now is we've rearranged Newton's second law's equation in order to solve for mass. So all we've done is rearrange the equation to solve for mass. So now we have our relationship mass equals this. So now we need to find the ingredients, one of which being net force, which we are already given. That is easy. So we have mass equals 150 over acceleration. So we just found our net force and put it into our formula to find mass, our final product. With net force found, all you need to find that is left is acceleration. So how do we find the acceleration? As previously mentioned, you can find acceleration in this velocity time graph because acceleration corresponds to the slope because it is rise over run, velocity over time in this case. So I rewrote the equations, the full equation, and so given this equation for acceleration, using the points that I've circled there, we are going to solve for the slope, the acceleration. So final velocity is 16 minus final initial velocity 12. And that would go over the corresponding times. So the final time, which is corresponding to the final velocity being 16, would be 4, and then initial time would be 3. So now, doing the subtraction first, you get 4 over 1. And then doing the division, it's just 4 meters per second squared. Remember the units. Always remember the units. So now all you do is substitute that into your original equation of mass equals net force over acceleration. So you've got your net force 150 over acceleration 4. So 150 over 4 equals 37.5, which you can round to 38. So we substituted in the acceleration to the equation, and then it did the division. 150 divided by 4 equals 37.5, or 38 kilograms. So that's how you find the mass, and that's how it's done.